So now we are going to see how you can do the hypothesis testing using Python. So if you recall, then we started this week with your one mean test, and for that we considered when standard deviation is known to you, and the second case was when it is unknown. So first of all, we will begin with the known sigma and the right tail test for that. So let me just write the comment over here, known sigma, and we are going to do the right tailed test. Okay, so in right tail test, you know that what is the hypothesis? The null hypothesis in that case is that, so let me just mention over here, so h, so let me just comment it. So h naught basically in that case would be that mu is less than equal to 40 versus your alternative that mu is greater than 40. Suppose 40, or you can consider this as mu naught, or since here we are going to take the null mean or the hypothesized population mean as 40, so I have just kept this as 40. Okay, so this shows that mu naught is 40 basically. So to begin with, let us import the necessary libraries. So we are going to import scipy.stats as stats. So basically we are importing this module as stats, which provides statistical functions and distributions. Okay, so since here we are going to deal with your normal distribution, so here this scipy would contain your normal distribution also. Let us write what are the sample data points given to us. So let us assume that this sample mean is 42. Okay, and since in this case we know the sigma, so we would write population std suppose as 10, sample size let that be 30, and your hypothesized mean value is basically, you can write the null mean as 40. Okay, so these are the sample data and population parameters. Okay, so this is sample mean. You have taken a sample in order to test or verify the claim that has been made, and you know that population standard deviation is 10. You took a sample of size 30, its sample mean came out as 42, and you are interested to check whether mu is greater than 40 or not, right? So the next step here after writing the hypothesis is you have to find the z-score or the test statistic over here. So the test statistic we will calculate the test statistic. So let me use z star because we use that same notation there. So what is the formula for that? Sample mean minus mu naught divided by sigma by root n, because this test statistic is calculated under the null hypothesis. Okay, so mu naught, that is equal to sign is there. Okay, so we will write sample mean minus null mean whole divided by pop std, okay, divided by sample underscore size raised to the power, because we have to take the square root of that, so we will write 0.5. Okay, so x bar minus mu naught divided by sigma, that is your population standard deviation, divided by root n. Okay, so this is your z star, and then we will set the level of significance. So let that be alpha be 0.05. Now you could calculate the critical value if you are using the rejection region approach. Calculate the critical value for the right tail test. So this one would be critical underscore value stats dot norm, okay, dot ppf. Okay, so basically we are finding the critical value using this percent point function, which is inverse of cumulative distribution function for the standard normal distribution. So here we write 1 minus alpha. Okay, so you can note over here that I have written stats.norm.ppf, and in the bracket I have written 1 minus alpha. And if you remember in the lecture, I said that you are going to reject the null hypothesis if z star is greater than z alpha. So it means that z score is calculated at alpha value, right? However, I have written over here 1 minus alpha. The reason is that because we are working with this ppf function, which is the primary function in Python for finding the critical values. Now what it does is that it is going to return the z score such that the area to the left of this score is 1 minus alpha. Okay, so basically you see that obviously below the curve, if you go beyond z alpha, that would be alpha region, right, where we reject the null hypothesis, and that is what we consider in the theory. Now when you consider to the left side of it, that is 1 minus alpha. So what this ppf function does is that it returns the z score that corresponds to the given cumulative probability from the left side. Okay, so this ensures that the area in the rejection region, that is the right tail of the distribution, is exactly alpha. So both of these are the same things. It is just because the way the function ppf is defined in Python. Okay, so it looks at the z score from the left side. Okay, and if you want to directly use like you do not want 1 minus alpha, you want to use alpha only, and you want to maintain that similarity between the theory and the Python code. So there is one more function that is defined as inverse survival function in Python. So instead of ppf, you can write isf. Okay, so same thing would be there, and 1 minus alpha, and you would replace 1 minus alpha by alpha, and that would return the z score for which area to the right under the normal is alpha. Here in this case, it is considering the area to the left of this score is 1 minus alpha. Okay, so both of them will give the same result. So in this course, we are going to work with this ppf function. That is why wherever we are working with the right tail, you will see that alpha would be replaced by 1 minus alpha, because that is the area to the left of it below the curve. I hope that is clear, that why we are taking this as 1 minus alpha. Now you can compare the test statistic to the critical value. Okay, compare the test statistic that you have calculated over up here, test statistic, to the critical value. Okay, so what you have, you will write if statement. If the z star is greater than the critical value, critical underscore value, then you would print reject the null hypothesis. Okay, else, this else would be coming here, print we fail to reject the null hypothesis. Okay, so what we have done over here, because first of all we have found out the critical value, that is z alpha, z star is there, z alpha is there basically, or you can say the critical value, and we say that we are going to reject the null hypothesis if z star value, that is the test statistic that you have calculated, is greater than the tabulated value, that is the critical value. If it is so, then you reject the null hypothesis, otherwise you will fail to reject the null hypothesis. Okay, it shows that you failed to reject the null hypothesis. Okay, so let us see what were these z star values. So let me just mention what is z star. Z star was 1.095 and your critical value came out as 1.64. So you can see that your z star here is less than your critical value. So you fail to reject the null hypothesis. Okay, so this is about your right tail test. In the same way, you can perform your left tailed test also. So let us look at that. So let me just use this left tail test. What will be the hypothesis over here? If it is left tailed, so it would be greater than equal to here, and you are interested to show that mu is less than 40. This is your left tail test. Okay. Now let us use the same data. So we have already imported this scipy.stats library. So sample mean is 42. So maybe I could write this again. Okay. In fact, if you see, you can just copy the entire thing. I will tell you where the difference will be. Because if you remember, in theory also we have minute difference between when you are going from right tail to left tail, right? So hypothesis is this. So obviously these values are same. Z star would be calculated in the same way. The difference comes when you are calculating the critical value. So in this case it would be alpha only, because this is the lower tail. So it will find the Z score that corresponds to cumulative probability from the left. And if you look in the left tail also, so the area to the left of it is alpha, right? If you visualize the normal distribution, standard normal distribution, right, and you consider minus Z alpha value, so basically there also you consider the area to the left, right? PPF function is considering the area to the left of that particular value. So basically it is going to be the same, right? So here also we will have, and this Z score, if you see, this is indeed the negative Z alpha value. Okay, because there it is because of symmetric, and we will have negative values to this side. Now you are going to compare the test statistic to the critical value, and you would say that if Z star is less than critical value, you would reject, otherwise you fail to reject. So let us run. So again you fail to reject the null hypothesis. Okay, so let us see what are the values that it has taken. So that would be same because we have entered the same data points. So here let us look at the critical value. So difference. So here it is minus 1.644. That was obvious, right? Okay. So this critical value is already minus. You are comparing it with minus value. So this value Z star is not less than this. So that is why you fail to reject the null hypothesis. Okay. So I hope it is clear why here we are not using 1 minus alpha, because it is a left tail test, and we are interested to find the Z score that corresponds to the cumulative probability from the left. And from the left also, if you see, the area to the left of that point would be alpha only, as opposed to your right tail, because in that case area to the left of that point is 1 minus alpha. So now let us write the code for your two tail test. So we can use some part of this as well. So here it would be your two tail test. So here mu is equal to 40 and versus mu is not equal to 40. Okay, this is your two tail test. We have seen it earlier also. So we'll import this library. Obviously you have already imported it, and sample mean. So I'm writing this statement over here because in case if you are just starting from scratch, then you should know that you should import this particular library. Okay, so you will have the sample mean as 42, population standard deviation as 10, sample size is 30, null mean, that is the hypothesized value, is 40. You calculate the Z star. The Z star is fine, alpha till here we get the same value. Now you have to find the critical values. Now in the two tail test you will have values on either side, right? So minus alpha by 2 and minus Z alpha by 2 and Z alpha by 2. So let us write the critical values for this, calculate the critical value. So let me write, I can copy this. So critical value, first let us write for the left side. So it would be stats.norm.pf alpha by 2, right? So here we are using this particular function, okay, to find out the critical value for the left tail, and we use alpha by 2 because it is symmetric, so alpha is split between the two tails, right? So alpha by 2 is used to find the critical value on the left side, and PPF uses the area below the curve that is left to this point, that is to the z-score. So that is why we write alpha by 2, and if we have for the right tail, it would be basically simply minus of this whatever you have obtained here, right? Because both these values are same with just the difference of negative and positive sign. So here this value, that is critical value left, which is basically the critical value for the left tail. So in this case, it is indeed a negative value itself. It will give you a negative z value. So when you take a minus, it would go in here in the right tail, you would get a positive z value. Fine. So now once you have calculated this, we can compare the test statistic to the critical values. So let me reuse this. So what was the rejection region there? You reject the null hypothesis if absolute value of z star is greater than or equal to z alpha by 2. So in this case, we would write if z star is less than critical value left critical value, or z star is greater than this critical value right tail. Okay, you consider on either side. If any of these conditions is satisfied, right, if z star, that is your test statistic, is less than the left tail critical value or it is greater than the right one, so you will print reject the null hypothesis, else you would fail to reject the null hypothesis. Okay, so again here also you fail to reject the null hypothesis. So let us see what are these values. It is -1 point CUC. Here it is giving you a negative value already. So here it would be just, because we are using minus of this, so it would be 1.95. And you fail to reject the null hypothesis because z star, as we have already seen, z star basically is 1.09, right? So it does not fall in the rejection region, and that is why we fail to reject the null hypothesis. Now if you suppose you want to write the code for your p-value approach also, okay, so maybe I could write it over here only. What will happen? So calculate. So first of all, you will calculate the p-value for the two-tail test. So let us use this. P-value is equal to twice of 1 minus stats dot norm dot CDF. You will consider the absolute value of the z star. Okay, so this will be your p-value. And what does it mean basically? So basically you are using stats.norm.cdf function, right? And you are calculating the absolute value of this z star that you have calculated here, that is 1.09. so obviously it would be same in this case. So it will compute basically the CDF for the absolute value of the z star. This function basically would calculate this CDF, right? And since we are interested in tails, we need to find the probability of observing a z-score as extreme as this absolute value of this or more extreme. Hence, you subtract the CDF from 1. And when you do this, basically what you do here, we are trying to find the probability of observing a value which is greater than absolute z-score finally, and you are multiplying it by 2 because we are working with the two-tail test, right? So you will have values on either side, right? You can have extreme observations on either ends, so that is why we multiply it by 2. And now you can compare the p-value. Compare the p-value with the alpha. So if p-value is less than alpha, you print p-value approach, because just to distinguish between the two, reject the name, reject H naught, I can write. Else print, let me use, so it would be fail to reject. Obviously it depends upon you what you want to print, so I'm just using the short form over here, fail to reject H naught. You can write the entire null hypothesis thing also. So p-value approach, it is printing. So initially you have from the test statistic here, you already have fail to reject the null hypothesis, and p-value approach is also giving you the same conclusion that you fail to reject the null hypothesis. So let us see what is the p-value actually. So p-value is 0.27, okay, and your alpha was 0.05, so obviously p-value is greater than alpha, so you fail to reject the null hypothesis. Okay, so when your sigma is known to you, so this is how you perform or write the code for your hypothesis testing. Okay, and obviously for writing the code you should know what are the steps, proper steps, because if you do not know what is the theory behind it, you cannot write the code for it, because you should know what is the critical value, how you compare it. If it is left tail, then what will be the rejection region, and if it is right tail, how it should vary. So all these things you should know. And obviously here we are directly using the sample mean, population standard deviation values. If you are given a data set, you can use that data set to find out what is the sample mean, standard deviation and all those values, and then you can substitute it over here. And we have worked with data in the initial classes, and you know that how you can find sample mean given the data set, right? So np.mean, np.standard deviation, np.var. So using those things you can find out, or you have to find the sample size, you can use the length function, len was there. So all those things you can use, and finally do the hypothesis testing. So now let us consider the case when sigma is unknown. Okay, when sigma is unknown. So we will first of all import numpy as np, okay, because it is used for your numerical operations, and then we will also import scipy.stats, import scipy.stats as stats over here. So let us consider that you have a sample data. We are considering a very small size data. So sample data. So sample underscore data, basically it will be an array that will contain your sample data. So let me just mark, like suppose it is 18.3, 20.1, sorry, 20.1, 19.7 we can take, 21.2, 22.5, 20.8, 18.9, 21.6. Okay, so this is an array that would contain your sample data. Now what we will do is we will set up the hypothesis for this. So let us consider that your null mean in this case, that is your hypothesized value, is 20 and alpha given to you is 0.05. Okay. So let us calculate the sample statistic, because as I was saying earlier also, if you're given any data set, then how you will calculate the sample statistic. So let us find out the sample mean first. So it would be calculated using this numpy's mean function. Okay, so this here you will write this sample data. Okay, next what do you need? You need the standard deviation also. So sample underscore std. For this you will again use numpy's std function, and you will write sample underscore data, and you will also specify that we are dealing with your sample variance. So that is why your denominator there, it should be n-1 and not n. And the sample size finally would be the length of this, right? So we have used these functions earlier also. So this is how you can calculate your sample statistics. So obviously here it is a very small sample and you can consider the larger ones. So in real life you would come across larger sample sizes. So now you can calculate the test statistic. So the test statistic, when sigma is unknown, so you know that your T star basically was sample mean minus mu naught divided by S over root n. That is sample standard deviation, right? So in this case, let us write T star would be sample mean, sample underscore mean, what you have calculated, minus the null mean, and you are dividing that by sample std divided by sample underscore size 0.5. Okay, sample standard deviation and divide by sample size. Okay, I hope this is correct. Yeah. So x bar minus mu naught divided by S over root n. So that is why you are raising it to the power 0.5. Now you can also calculate the degrees of freedom because you are dealing with the t distribution. So you can write sample size, whatever is the sample size, minus 1 would be your degree of freedom. Okay. Now we can calculate the critical values. So in the previous case, we considered left, right and two-tailed separately. So here we would write all of them together. So that is why you can see I have not specified the hypothesis till now. So we will do it together. And now we will calculate the critical values, and critical values will be calculated for each of the three tests. Okay. So we will write the steps for that. Calculate critical values. So first of all, we will calculate critical value for the right-tailed. For right-tailed, as you know, we will use stats.t.ppf. So in the previous one, we used stats.norm.ppf. And here again, it will be 1 minus alpha. And here, in addition, we will also specify the degrees of freedom. So again, you see that for the right-tailed test, we are writing 1 minus alpha. So because you are going to reject the null hypothesis when T star is greater than equal to T alpha. So you specify the T value, T score at alpha and the degrees of freedom. Okay, n minus 1. So here we are writing the same thing, and for the left also we can write. So let me just mention that. Left-tailed, it would be just alpha. Okay, as I've explained the reasoning earlier also, because it will find the z-score that corresponds to the cumulative probability from the left side. So it is finding the t-score here. Now for the two-tailed, what will happen? So let me just write critical value. So I am writing two-tailed here. So value 2 means that I am writing for the left and the right tail. So for left tailed, first let me write it would be alpha by 2 because alpha would be divided into two parts. So alpha by 2 with the corresponding degrees of freedom, and the other one would be for the right side. So here it would be 1 minus of alpha by 2, or you could simply write minus of whatever is to this side. Fine. So here you will get some negative value and then it would be positive to this side. Fine. So we have calculated the critical values for the three different tests. This is for right tail, left tail, and this is for the two tail test. Now if you have to do your right tail test, so right tail test, then what you will do? You will write if t score is greater than t star is greater than your critical value underscore right. If this holds true, you will print right tail test. This has to be in double quotes. So right tail test, you will reject H naught. Else what you will print? You will again give this print statement with just the difference that here it will be fail to reject. So why we have written this? Because in right tail test, what is your, let me write, what is your null hypothesis? So null hypothesis in that case is that mu is less than equal to mu naught. So mu is less than equal to mu naught over here is 20, versus alternative would be that mu is greater than 20. So this is your null and alternative for the right tail test. And if that is the case, what is the rejection region in that case? It is t star. If t star, that is you have calculated this test statistic, is greater than your critical value t alpha, then you reject the null hypothesis, otherwise you fail to reject it. So you can see that right tail test is giving you fail to reject the null hypothesis. We can also look at your critical value. What is the answer to this? It is 1.89, and alpha, obviously it is very much more higher than your t star value, right? So let me just look at the t star. Yeah, so t star is 0.77 and critical value is your 1.89 approximately. So t star is less than the right tail critical value. So we print fail to reject the null hypothesis, right? So same way here only, I can add these steps for your left tailed, and I can basically use this same command over here. Okay, so let me write for the left, sorry. If it is left tailed, what will be your hypothesis? Here it would be greater than equal to, and this side it would be less than 20. Okay, and if t star is less than critical value, that is for the left tail test, then it would print left tail test, you will reject the null hypothesis, and left tail test, you would fail to reject the null hypothesis. Okay, so both of them are failing to reject the null hypothesis. Fine. Now let us do for the two-tailed also. So in this case we have mu equal to 20, and this say it is mu not equal to. So 20 is the hypothesized mean value that is given to us. So if t star is less than your critical value 2, this would be left here, right? Because we look at the absolute value of t star is greater than equal to t alpha by 2, right? So we can write it as if t star is less than this left tail critical value, or t underscore star is greater than this right, critical value to the right side. In that case, you would print the two-tailed test is rejecting the null, and this side it would be failing to reject the null. Okay. So obviously in all the three cases we are getting your failing to reject. So let us look at what are the values. So critical value to the right tail we have seen. Let us look at the critical value the left side. It is minus 1.89, right? So minus 1.89, and you have to compare this with your T star. So T star is 0.77, right? So T star is greater than your critical left tail critical value, so you fail to reject the null hypothesis in this case. And likewise, if you consider your two-tailed also, so let me just check. It is minus 2.36, right? So to the left it is minus 2.36 and the right tail would be 2.36. So your value T star is 0.77, so it does not fall in the rejection region, and hence we can conclude that you failed to reject the null hypothesis. If you want to give a proper printout statement for this, you can add after here. It would print the corresponding critical values. So this is how you do for the situations when your mean is, you have to find out the hypothesis, you have to test for the mean, and you can either go with the sample standard or the deviation is population. So basically these are the codes that you write in the Python when you are dealing with hypothesis testing for one mean, as it would be different in different situations. We have seen when sigma is known or unknown, and for different types of tests also it would vary.